most universes, we know that they're not ones in which matter acts like matter in our universe. But there's a much trickier thing to think about. Gravity weakens as 1 over the distance squared. This is a direct consequence of there being 3 dimensions of space. In your scenario, gravity exists in both our universe and the parallel one. That probably means that there are 6 dimensions, which means that gravity should weaken as the 5th power of the distance. Now, obviously, such statements depend critically on the exact multiverse model you're considering and how dimensions work and all that. But hopefully you see that your supposition would require some disciplined effort to carefully lay out a well-developed theory. Gitesh Lashkari asks what the path is for becoming an astrophysicist. Hi, Gitesh. That's simple. Start out trying to be a particle physicist and fail. Your fallback plan would be an astrophysicist. Okay, I'm kidding, of course. I actually think astrophysics is totally awesome. No, the answer to your question is pretty much the same for any field of physics. Basically, you need to do well in high school and learn science, mathematics, and English. Then you go to a university and study physics. Note, I didn't say study astrophysics. For an undergraduate degree, you should get a firm grounding in basic physics. It's in graduate school that you begin to specialize. Now, my advice for graduate school is to attend the most prestigious graduate school that will accept you. That means getting good grades in your undergraduate career. This is mandatory. One thing that is not as obvious is the need to do research as an undergraduate student. Ideally, this would be in astrophysics, but that's not super important. The important thing is to get some experience when you're young. That will help you get into a good graduate school. I should probably point out that the details vary from country to country, but what I've said here is pretty universal. Still, you should ask a physicist in your country for advice. It's just safer. Good luck. Vivek Yadav asks if the laws of physics can change over time and if dark matter might convert into ordinary matter. Hi, Vivek. We're pretty sure it can, and this isn't supposition, it's data. For instance, we can look at galaxies in deep space. Light from those galaxies took millions, billions, or as much as 14 billion years to get here. The laws of physics always seem to be the same throughout the history of the universe, so we can rule out your conjecture with some certainty. Banang points to my favorite tree metaphor and asks if dark matter can be multiple leaves on the tree. Hi, Banang. You make a good point. Cosmic neutrinos are a form of dark matter, as are black holes, brown dwarfs, etc. However, we now know enough to know that neither of those things can make up the majority of dark matter. Dark matter is 5 times more prevalent than ordinary matter, and neither neutrinos nor black holes are anywhere near enough. After decades of work, the favorite explanation is that dark matter is likely to be a single form of undiscovered matter. On the other hand, until we've solved the dark matter puzzle, we need to not be closed-minded and focus on a single answer. It remains possible that dark matter is multiple leaves on the tree. However, we can definitively say that we've ruled out many of the leaves as being the main solution to the dark matter mystery. Dam notes that dark matter doesn't interact with light and asks if we could run into dark matter in outer space. Hi, Dam. I think the answer is no. After all, when we touch something, what is going on is an electromagnetic reaction between atoms. Dark matter doesn't experience electromagnetic reactions, so it's likely it would pass through you, just like neutrinos do. Good question. Giovanni P. notes that Mercury orbits the Sun faster than the outer planets and is asking how this applies to galactic motion. Hi, Giovanni. What you said is true, but there is a key difference. Planets orbit the Sun, which is a concentrated form of mass. Stars orbit galaxies, which are a distributed form of mass, and, just as important, stars are actually inside the galaxy itself. The orbit of stars inside the galaxy are governed only by the mass of other stars inside their orbit. The ones outside don't matter. It's easy to show this by inventing an imaginary galaxy that is a solid sphere. According to Newton, the orbital velocity of a star inside the sphere increases as a function of distance from the center and drops off outside the sphere. You can see what I mean here. And I put a link to a paper in the description that shows the relevant math. In the case of real galaxies, the drop-off in orbital velocity at large radii is because the star is outside the galaxy and the mass of the entire galaxy is governing the star's motion. That's like when planets orbit the sun. Good question. Art Camp 7 asks if the phenomena of light bending around his or her finger when held up to a bright light is the same as gravitational lensing. Hi, Art Camp. Actually, no, it's not. Light bending around your finger is a phenomenon called diffraction, and it's a behavior that waves do. All waves bend around corners. The gravitational effect predicted by Einstein is a different thing entirely. And finally, Michael Kingsford Gray claims that dark matter is the modern form of luminiferous ether. Hi, Michael. There's part of me that agrees with you and part that doesn't. It's certainly true that the term dark matter is a placeholder name for a solution to the mysteries I described in the last episode. We don't know the true nature of dark matter, or even if it exists at all. However, there never was any evidence for the existence of the ether. It was simply a postulate because nobody could imagine that electromagnetic waves like light could travel without a medium. After all other forms of waves need a medium. When Zwicky invented the term dark matter back in the 1930s, it was just a placeholder. But dark matter is a more advanced concept these days. Many, and I mean many, postulated explanations have been falsified. Killing ideas is not the same as discovering ideas, even though they are both crucial steps in the scientific process. But an honest person must admit that we don't know the final solution of the mystery of dark matter. We need to be open to all possibilities that have not yet been ruled out by measurement. Okay, so that's all the time we have for questions today. Actually, we went a bit long enough that I don't have time to ask you to like, subscribe, and share. Oops, I guess I just did. But I couldn't help talking so long. Get me started talking about...
All right, we're going to continue talking about that because, I found it interesting enough to be able to connect with the electromagnetic energy and also the ether, the luminous ether that was described in the question and answer portion on dark matter. Yeah, we might want to look up these subatomic
Look
stories.
at this beautiful green and blue ball and try to find where you are located. Where are you from?
All right, what was this that just popped up? Man. Anyways, that was another video back there. Okay. Back to where I was about this latest video we were just seeing why dark matter seems likely. He says there's an existence of dark matter, and the modern problem is, the fact that these subatomic particles never know. Yeah, it could be a real thing. And as we were just observing him talking about the electromagnetic energy, the neutrinos that travel through and trigger earthquakes on our planet by heating up the Earth's core, Dutchy, if you're up to speed yet. And also into the fact he was talking about this ether. Man's, described this electromagnetic radiation in the fifth element. They call it the mysterious fifth element. Yeah, that's what I keep trying to get to everyone on. We're getting up to speed in Fermi Laboratory, this, behind dark matter and trying to, address all these conspiracy issues and theories, explaining the mysteries of our universe since the beginning of time, written in, the ancient text by our man, Codex. That's what I'm just trying to be up front about.
Hello, and welcome to another Fermilab at Home lecture series. I'm Tom Carter, your host for this evening, and I'd like to say good evening, good afternoon, and even good morning to our audience that's in just about every single time zone on the globe. I'd like to say a bit about our upcoming talks in this series. On September 11th, Dr. Don Lincoln will speak on Understanding God's Thoughts, Einstein's Unfinished Dream. Dr. Lincoln is going to explain the current status of Einstein's timeless quest and give the audience a sense for the prospects of completing this work. On October 16th, Dr. Jennifer Raff will speak on how particle physics might save your life. She's going to talk on how particle physics scientists were involved in building a simplified mechanical ventilator as part of the COVID relief effort. A bit about the mechanics of this night's talk. A closed captioned recording of this talk will be available on our website shortly after we're done.
These sorts of lectures. So let me begin with some kind of sweeping or grand remarks. I think it's remarkable just to think about the fact that throughout the entirety of human history, people in all times and all cultures have looked up at the night sky and wondered about their universe and how it came to be. In this respect, we have a lot in common with our ancient ancestors. But in one important way, we're different. We're unique. We're unique in the sense that we happen to be lucky enough to be living at the one time in history where we can look up at the night sky and honestly say that we more or less understand what it is we're looking at. Take this image, for example. This is something, an image taken by the Hubble Space Telescope as part of what is known as the Deep Field program. Most of the blotches of light in this image are not stars, as you might have guessed, but they're actually entire galaxies, similar in size and shape to our own Milky Way. But because it takes time for light to travel across space, this picture doesn't show us what these galaxies are like now, but what they were like over 13 billion years ago, only 400 million years after the Big Bang. Our universe was a very different place than it is today. It was smaller, it was more compact, and it was hotter. And we can honestly say that we understand pretty well how and why our universe has transitioned from this early state into the universe we find ourselves living in today. A little over a century ago, science didn't have anything to say at all about our universe's distant past, and certainly nothing to say about its origin. The laws of physics as we understood them before the 20th century simply didn't have give us the tools that we needed to conceptualize how something like space could transform or begin. But this all changed with the invention or introduction of the general theory of relativity by Albert Einstein in 1915. Prior to Einstein, physicists thought of space as an unchanging backdrop, something that was static through which objects could potentially move. But Einstein showed us that this is only the beginning of what space and time is really all about. He showed us that space could do things. Space could curve, it could warp, it could change, it could contract, it could expand. In fact, the equations of Einstein's theory could be used to show that the one thing that the space that constitutes our universe could not do was stay the same. It really had to be contracting or expanding with time. And in 1929, the astronomer Edwin Hubble, with his collaborators, showed for the first time observationally that our universe is in fact expanding. The volume of any given piece of our universe is getting larger as time progresses. So if you're like most people, you've heard before that the universe is expanding. This is part of our popular culture at this point. But also, if you're like most people, you probably don't have a very good idea what this really means exactly. So let me try to shed some light on this subject. What Hubble actually observed with his telescope in 1929 is that all of the galaxies he could image seemed to be moving away from us. Furthermore, the farther away from us a given galaxy is, the faster it seemed to be receding. We now understand that what he was really observing is the fact that space, the amount of space between any 2 points in our universe is getting larger as time advances. The volume of space itself is growing as time goes on. Now, I've given a lot of public lectures on this subject and related subjects, and I've done it enough in person to know that around this time in the talk, a large fraction of my audience comes up with the same question. And I bet a lot of you are wondering the same thing right now. If I were in the room in person with you, I would ask for a show of hands of how many of you right now are asking yourself the question, what is the space expanding into? It sounds like a pretty good question, but it doesn't have a very good answer. The reason it doesn't have a very good answer is because if space were expanding into something else, I would call that something else space. And when I say space is expanding, I don't mean that part of space is expanding. I mean that all of space is simultaneously expanding in unison. So when cosmologists say that the universe is expanding, they don't mean that part of space or part of the things in space are moving into some previously unoccupied part of the universe. Rather, they mean that the volume of the entire universe is getting larger as time goes on. From the fact that space is expanding, we can begin to infer some things about our universe's distant past. In particular, since it's expanding, that means the volume of any given piece of space was smaller in the past. And in order to fit all of the matter and energy that we have in our universe today in that smaller volume, we can deduce that the universe in the past must have been much more dense and much more hot. This is the basis of what we call the Big Bang Theory, the idea that over billions of years, our universe has expanded and evolved from a hot, dense state that we call the Big Bang into the universe we find ourselves occupying today. Before moving on, I want to comment on one common misconception about the Big Bang. When people think of the Big Bang, they can be tempted to imagine that it was an event that took place at some particular location in our universe, like a cosmic explosion that grew out of a location into the rest of the universe. But that's not what we mean. When cosmologists talk about the Big Bang, they don't mean something that happened somewhere specifically in space. They mean something that was a state that the entire universe was in 13.8 billion years ago. So the Big Bang that happened, here or anywhere else, it happened everywhere at the same time, including the place in our universe we occupy right now. All right, so let's take a little bit of a different pivot here, and let's talk about the timeline of our universe's history, the main events that have unfolded since the Big Bang. So here I show a timeline, a cosmic timeline, and a few of the key events are shown on it. In particular, you can see where the first stars began to form about 200 million years after the Big Bang. These stars were a lot larger and shorter lived than most of the stars we have in our universe today. And only now are astronomers about to introduce the kind of technology that we think will produce the first images of this first generation of stars. About 9 billion years after that, our own star, the sun, and the planets that make up our solar system all formed. And then about 4.5 billion years later, life in the form of human beings emerged on our planet's surface. Notice that on this chart, all of human history, from Homo sapiens and Homo habilis and prehistory all the way forward, occupies less than a fraction of a pixel. From this perspective, the role of human beings in the universe might seem inconsequential, even though to all of us, I'm sure human history has played an outsized role in our view of important things in our universe's history.
All right, I'm going to pause there. We're talking about the timeline through history. Boom. Because you see, the thing about it is, when we talk about timelines, there looks like there's a beginning, and well, we haven't reached the end yet, because obviously there should never been a beginning if there's if there's infinity, or things that make me wonder about all this on the edge of time, exploring the mysteries of the universe. How about this news that really is fascinating? The fact that we're going to do time travel. This is where it's all leading to. You know that, don't you? This is where this show's going to, and arriving and bringing into the mix. The science of time travel now is being post-populated as an idea, a hypothetical thoughts of how we may be, in fact, in the middle of this paradox when we arrive at the next event of time travel, breaking the timeline. You know what I'm saying? So we got a beginning in the time travel. Once we figure out when they break timeline to travel in time, well, we got to break the timeline to travel in time. That's the whole main concept of time travel. We got to break the timeline to travel in time, forward or backwards. Somewhere going to snip the scissors, and they're going to cut that timeline. All right.
So the timeline we're looking at right now, there's nothing wrong with it. All the things I've drawn on it are correct. But as far as a cosmologist might be concerned, this is a pretty dull way of showing cosmic history. It's dull because it doesn't emphasize the most exciting parts of our universe's evolution or unfolding. Instead, we like to show timelines that are a little bit more like this one. Instead of a linear timescale here, I'm showing a logarithmic timescale. Each tick mark shows a factor of 10 in time passing. This allows us to look much, much closer to the Big Bang itself and farther back in time, where many of our most exciting events took place. In particular, you can see on this version of the timeline, the transition that took place about 380,000 years after the Big Bang, when the first atoms began to form.
Oh, so this makes some more sense, that the timeline began by a Big Bang is what many scientists believe, and that's why we have to find the God particle, and that's why all these charged particles and cosmic rays and gravity waves. You know what I'm saying? Everybody figure this shit out? Yeah, wormholes are coming up. We got black holes. Yeah, we got gamma rays coming from black hole collisions. We got dark matter. We got space quakes. And then we got Big Bang, you know. So at the beginning of time, we had a Big Bang. And now when we figure into the mix, many believe that through 0-point physics, how about Doomsday Dutchie? Let me give you a shout out to his damn ass once again in predicting earthquakes. This fucker, no mofo, talking about scalar weaponry and Tom Bearden. But hey, man, let's get to the 0-point physics, you know, particle shit. Yeah, particle astrophysics. You didn't bring up. Yeah, you're a little slow on harp rings. Yeah, figuring in predicting tornadoes, watching radar, you know, circles. Shit. Yeah. But now we have, you know, add into the fact it all today makes a lot more sense, doesn't it, Dutchie? Yeah. We got portholes. How about them portholes you saw, man? You got your radar 3D magic crystal earthquake crystal ball working there for them wormhole portholes they're opening up for time travel yet, Dutchie? Because we're going to get to that next. We got a whole bunch of good shit in this show coming up.
These atoms began to form at this time because of the temperature that the universe was maintained at this moment in cosmic history, which was about 3,000 degrees. There's a background of radiation that fills our universe today, but it's cold today. It's only about 2.7 degrees above absolute zero. But 380,000 years after the Big Bang, the entire universe was filled with a plasma of photons and electrons and other charged particles maintained at a temperature of 3,000 degrees, or about the temperature of the surface of a red star. It was around this temperature that atoms began to form, because I like to think of 3,000 degrees as the melting point of many kinds of atoms. What I mean by this is, if I took some atoms and I heated them up to a temperature greater than 3,000 degrees, they would begin to fall apart. Their electrons would break off. So instead of a gas of electrically neutral atoms, you'd find yourself with a plasma of photons, electrons, and nuclei, all interacting in a frequent, complex way. For a plasma, it turns out light cannot generally travel through such a medium. The plasma is opaque to light. Shining a beam of light through the early universe would be about as effective as shining a flashlight directly into the Earth today. It just will not penetrate that sort of medium. But as the universe expanded and cooled, eventually those electrons began to bind to those nuclei, forming electrically neutral atoms, or complete atoms, for the first time. And as this happened, our universe got more and more transparent. So as our universe evolved from an opaque state into a transparent state, suddenly an enormous amount of light was deposited into every corner of our universe. This light has been traveling through the universe ever since, and it in fact fills our universe. What I'm referring to is the cosmic microwave background, the light that was generated in the formation of the first atoms that we can measure in great detail today. What I'm showing you here is an image of that very light, the cosmic microwave background. The hottest and coldest parts of this light tell us where the least and greatest density regions of our universe were 380,000 years after the Big Bang. This not only tells us what our universe was like in that primordial state, but what forms of matter and energy occupied space, and how fast our universe has expanded and evolved ever since. This data set is truly a treasure trove to cosmologists, and it gives us a great deal of confidence that we understand our universe and its history from a few 100,000 years after the Big Bang up to the present. All right, so let's go back to our timeline, but now let's go back to an even earlier time. Let's go back to the first minutes and seconds after the Big Bang, at which point the temperature of the universe was around 1 billion degrees. That's hotter than the core of the sun. And it's a temperature at which nuclear fusion can proceed extremely efficiently. So you can think of the universe at this time as being one giant nuclear fusion reactor. And it was around this time that the first atomic nuclei were being formed. Prior to this point, there were protons and neutrons in the universe, but no nuclei. The protons and neutrons were not able to fuse into one another until these first minutes and seconds. And through fusion, they formed things like deuterium, tritium, helium, and even a smattering of heavier things like lithium and beryllium. Using Einstein's theory of general relativity, combined with facts we accumulated about nuclear physics over the course of the 20th century, cosmologists were able to predict how much of these different kinds of elements should have been formed in the universe's first seconds and minutes. And then we went and compared those predictions to actual measurements of the abundances of things like helium, hydrogen, lithium, and beryllium in our universe. And lo and behold, we found a really good match, a remarkably good match. This gives us a great deal of confidence that our standard picture of the early universe's evolution describes our universe quite well, at least from a few seconds after the Big Bang up to the present.
There we go. You never know. He's talking about cosmic evolution. Yes, he is. He's talking about cosmic evolution. Okay. Let's flip him back onto this. Show you how this chemical wedding works. Yeah. Alchemy. Yeah, we could add in alchemy, can't we? With the May and fifth element fusing all this shit together. You never know. No, you don't. But let's get on to the mix, because we're hiding something from all you out there. You know that, don't you? The gravitational waves from these giant Big Bang explosions, time and space. Now I gotta shift it up here. So man, now I gotta take this. Hold on a second. I gotta do some changing around, do some art chart and targeting. Here we go. Because we're going back to this story, that bringing into the mix gravitational waves. The LIGO and Virgo scientific collaboration has detected gravitational waves coming from the massive black hole collision I was talking about earlier that was ever recorded. This gargantuan black hole belongs to a new class, as we were explaining. But not only the merger of a super black hole did we discuss, but now the signals from this black hole collision that created a new, larger black hole has detected gravitational waves. So what we're looking at here, the signals known as GW190521 was detected on May 21st, 2019, Dutchie. Doomsday Earthquake Dutchie, the space quake shaped for The short little wiggles that was less than a tenth of a second appeared to have been shock waves of a collision that took place some 6 billion years ago. So look back on your magic 3D earthquake crystal ball and look for May 21st, 22nd, and see if there was some major earthquakes that was converted into energy during this magnetic reconnection. Yeah, as it diffused on the Earth's surface. Well, anyways, this means that what I was talking about, we'll show you here in a little bit. Boom, how charged particles, the fifth element, cosmic rays, and the missing fifth element, yeah, means that it affects Earth's weather. Yeah, it sure does. Triggers earthquakes, Dutchy, like I pointed out the other day with the geomagnetic storm and the diffusion, electrical diffusion from the magnetic storm. But anyways, you would like to hypothesize about deep earthquakes triggering the ones somewhere else on the planet, like some kind of like boiling pot of water, waiting for you to waiting for your earthquake doomsday. Yeah, I'm still waiting on a big one there in California. So, needless to say, the big black hole, smaller black hole scenario suggests that the possible black hole collision step forward is similar to that, of small black holes. But they see now gravitational wave detectors and the massive black holes are found in the center of galaxies. So more in cosmic evolution. It's fascinating. The pictures are just terribly misleading. How space quakes occur. But hey, who am I to point out? Yeah, who am I to point this shit out? It all fits into science of cycles. Now, I need to go in here and bring up this article on wormholes. Time travel. We were just talking about all this timeline shit. So it makes... I had that up there, didn't I? Right there it is. Scientists say time travel via wormholes may be possible. Well, this is like out of the Big Bang Theory. Yeah, just like out of the Big Bang Theory. That's how wormholes, some theories may be possible. That's what I'm hearing. I'm hearing that's how you got to get through a wormhole. That's how they're going to travel through time, through a wormhole, or through, a Big Bang. So if you're trying to come up with the holy grail of scientific achievement, now let's toss into the mix the possibility of discovering the secret to immortality. Or tossing up the fact that developing time travel, which will come first. We're certainly not nearing the age where humans will live forever, but hey, let's tantalize the discovery of possibility of, dangling out there the fact that there are conditions that exist that Princeton researcher explains. It wouldn't take much to create a wormhole in space that would allow humanity to survive. Well, would humanity survive the journey? Well, let's see. I don't know. But fascinating. Never know. We just need to talk about this stuff a little bit here, because I got a lot of thoughts about this stuff going on. Yeah, I do. No doubt about it. I mean, we see the research on how it was possible of cosmic evolution carried out through studies that through this There may be dark matter at the center of black holes, but wormholes that move humans through space and time are possible. As you might expect, the research paper gets into some pretty intense shit. It may or may not be possible, so you never know. This microscopic, warped thoughts of time travel, going to be needing a little bit of more frickin' weed tomorrow, aren't we, everyone? Doomsday Dutchie doesn't smoke that shit, he says, huh? Well, I forgive him, because he don't know about space quakes and gravitational tidal waves yet, because he's a dumbass. But, you know, hey, who am I to point out? Maybe he'll watch this again. He'll be seeing my latest video and taking it over and sharing everyone and, you know, giving out and slopping out, you know, and giving, you know, serving up sloppy seconds like he always does. So one can't fucking not, you know, ignore the fact you gotta laugh at him. Because he got one fucking hell of a big ego, because he can't pull his head out of his ass to see that there are thousands of us that don't believe his bullshit earthquake forecasting fantasy. Because you never know what could spark an earthquake but opening a doorway to a wormhole in outer space as you pass through it. And suddenly, now, let's get to the deep space theory. Here we go. And the stargates. Yeah. Let's get right into it. Hold on. Hold on. Oh, yeah. Whoops. It didn't want to do that. Oh, man. See what I'm doing this in my studio. Oh, man. And you got all these layers. And when you click on these layers, you miss one. It's not what I wanted. I wanted to see this. Here we go. Okay. I want to try to, adjust this and shrink this. Because I'm trying to talk and make this stuff show up on. Oh, by the way, these patches you see and images that video I made behind me, in the scene behind me, yeah. Heaven's Gate. You remember that comet traveling from outer space? We were talking about that the other day. Yeah, we got the dark stars. Earth's companion sun that's headed this way. We've been thrown into the mix. Yeah. Of course, you have all these NASA patches that symbolize, of course, the Stargate theory. And then we add into the magnetic portholes that could open up. That could be opened up to travel in a wormhole. We'll get to that in a little bit. Hint, hint. Hint, hint, wink, wink. Yeah, we'll get to that in a little bit. Like I said, scientists believe time travel might be actually possible. Might actually be possible. Who would have thunked it? Hidden portholes in Earth's magnetic field. Yeah. Hidden portholes and might be the, we'll see what NASA has to say. Because Doomsday Dutchie's a little slow when it comes to wormholes, right? Know what I'm saying?
Hidden magnetic portals around Earth. Presented by Science at NASA. A favorite theme of science fiction is the portal, an extraordinary opening in space or time that connects travelers to distant realms. A good portal is a shortcut, a guide, a door into the unknown. if only they actually existed. It turns out that they do, sort of. And a NASA-funded researcher at the University of Iowa has figured out how to find them. We call them X-points, or electron diffusion regions, explains plasma physicist Jack Scudder of the University of Iowa. They're places where the magnetic field of Earth connects to the magnetic field of the Sun, creating an uninterrupted path leading from our own planet to the Sun's atmosphere 93 million miles away. Observations by NASA's Themis spacecraft and Europe's cluster probes suggest that these magnetic portals open and close dozens of times each day. They're typically located a few tens of thousands of kilometers from Earth, where the geomagnetic field meets the onrushing solar wind. Most portals are small and short-lived. Others are yawning, vast, and sustained. Energetic particles can flow through the openings, heating Earth's upper atmosphere, sparking geomagnetic storms, and igniting bright polar auroras. NASA is planning a mission called MMS, short for Magnetospheric Multiscale Mission, due to launch in 2014 to study the phenomenon. Bristling with energetic particle detectors and magnetic sensors, the 4 spacecraft of MMS will spread out in Earth's magnetosphere and surround the portals to observe how they work. Just one problem: finding them. Magnetic portals are invisible, unstable, and elusive. They open and close without warning, and there are no signposts to guide us in, notes Scudder. Actually, there are signposts, and Scudder has found them. Portals form via the process of magnetic reconnection. Mingling lines of magnetic force from the Sun and Earth crisscross and join to create the openings. X-points are where the crisscross takes place. The sudden joining of magnetic fields can propel jets of charged particles from the X-point, creating an electron diffusion region. To learn how to pinpoint these events, Scudder looked at data of magnetic reconnection.
Of magnetic reconnection, Doomsday Info Dutchie, did you ever identify these space quakes that trigger earthquakes on Earth yet, dummy? Huh? I've been trying to forecast them for a few decades now. Who am I to point this shit out to our little resident earthquake forecasting dummy? But also, let's add into the mix that it actually fits right into all what I've been trying to get at. Wormhole physics. 0-point energy physics. And the possibility that we live in a time warp loophole. Some may show, you never know, that, hey, as my math will figure it in, hey, we know we have a big bang at the beginning of time, but as time travel and tidal force waves are going to have to be made to travel in time again in the future. So let's take a short time break and say, hey, you know what I'm saying, dumbass Dutchie? We're going to have one major fucking earthquake when time travel begins here. We got it all plausibly figured out, the formation of how these spacequake equations that Mitch Petros began in space weather back in 1998. The theory, yeah. And the Mayans all do believe, too. They're thinking about, hey, our galaxy, our wormholes and black holes and this giant energy beam and burst is going to transform us during the 5th cycle of the sun that they believe every 26,000 fucking years. For those that are all into this interstellar movie shit like Dutchie is, that, trying to sell Doomsday Dutchie underground bunkers for everyone, including them at FEMA. So let's go, how deep does the wormhole go? Einstein theorized all this shit, yeah. And here, once again, I just made this special video. Let me zoom up here. I just made this special video today of all these pictures over the years. Because, how am I to point out to you that the Stargate things and the Columbia spacecraft exploding over Texas, it was all symbolized in, NASA's, dark wizard physics fantasy. Yeah. And there's Doomsday Dutchie. Well, he's out here trying to get a whole bunch of 400,000 people to subscribe to him because he can predict earthquakes. But who am I to say to show that the 5 elements of the universe sometimes have positive and negative energy, and they create space quakes. And maybe one day an unstable space quake so large and so unstable might produce a big earthquake. Yeah. Trying to open a wormhole. Maybe they were trying to do that on 9/11. There was a movie called Millennium that, depicted that sort of thing. Where'd all them people go? Yeah, right through the Stargate. That's where they went. Never know. Here I am. Never know. Right. Patriot Broadcasting and Liberty Tree Radio Field Reporter number 8,510. And as always, may God bless the Republic. Death to the New World Order. We're on the march. The Empire is on the run. We shall prevail.
All right, what's up, y'all? I'm Akil Gibbons from our Vice offices in Brooklyn, New York, and our colleagues over at Vice Columbia paid a visit to Victor Damien Rosso, a man who claims to be the son of Lucifer and founded a temple dedicated to satanic worshiping in the city of Quimbaya. This is Templo de Lucifer.
Estamos a punto de entrar a la iniciación que me van a hacer en la religión luciferina.
Lo vi a él, un ángel enorme con 7 alas. Va a organizar el ejército de los hijos de Lucifer.
¿Y el ejército qué finalidad tendría como ejército?
Enfrentarnos. ¿A quién? A la Gran Ramera.
¿A la Gran Ramera? ¿A la Iglesia Católica?
Tenemos a este hombre ante ti.
Hola, soy Andrés Páramo. Estamos muy cerca de lo que se denomina el templo luciferiano Semillas de Luz, regentado por un tipo que se hace llamar Víctor Damián Rosso.
Hola amigos de Latinoamérica, yo soy Víctor Damián Rosso Villagrán.
Soy fundador de la asociación Templo Luciferino Semillas de Luz.
Nos encontramos acá para entrevistarlo a él, para hacer un ritual de iniciación satánica y para mirar qué es lo que opina la gente, qué es lo que opinan las demás personas acerca de este fenómeno.
No, hasta ahora no se ha dejado de la cara.
Han entrado muchachas y han salido enfermas de la cabeza.
La manera de adorar a Lucifer es sacrificando animales inocentes, matándolos de una manera cruel para poder saciar con sangre e idolatrar esa imagen de Lucifer.
Nosotros hemos realizado una serie de procedimientos legales, no por los religiosos, sino por no tener los requisitos legales para la licencia de construcción. Sería una multa de 64 millones de pesos que tendría que pagar o, si no la paga, en un término, la demolición de dicho lugar.
Incluso que hasta la misma policía ha ido allá y cuando llega la policía no encuentran a nadie.
El diablo para uno es negativo, todo lo malo, antivalores.
Y aquí no fuimos a ver si de pronto desarrollamos algo allá y nos cerramos las puertas.
La gente que entrevistamos en la plaza principal de Quimbaya tenía una opinión uniforme acerca de Víctor Damián y su templo. Todos rechazaban la idea y miraban con algo de miedo y distancia el surgimiento de una religión luciferina. Otra fue la historia cuando viajamos a su finca. Alberto Trujillo, un vecino que trabaja para él en diversas labores, nos llevó en su camioneta contándonos un lado más humano y amable del hijo de Lucifer.
Sí, yo le hago vueltas a él.
Ajá.
Ni se trata de material, válgame tal cosa, como tengo muy listo.
Ya. ¿Y usted vive aquí, cerca de él?
Ahora la finca de nosotros linda con la de él.
Ya. ¿Y qué opina del templo?
No, cada cual con su tema.
Así sea satánico.
Ah, sí. Si es el diablo, estamos al pie de él, ¿sí o no?
Sí.
Estamos mal aquí, tenemos que cuidarnos al de él.
Bueno, ¿y él da miedo?
¿De tipo? No, es muy formal. ¿Muy formal? Ave María. Bueno, el templo apenas lo hizo hace fue un año.
¿Y no ha pasado nada?
No ha hecho nada.
¿No ha ido nadie?
No.
¿Y usted no le parece raro eso? ¿Un templo en el que no pasa nada?
Si uno le dicen que es para filmar películas de terror, ese es el cuento, que es para filmar películas de terror. De vampiros.
La finca tiene 2 casas, 2 piscinas, una colección de pastores alemanes y al final, lejos, una construcción grande con cruces invertidas. El templo visto desde afuera se ve solitario, cerrado y totalmente privado. Y para ser una iglesia, no da mucho la bienvenida.
¿Víctor o Héctor? Víctor es una marca registrada, pero mi nombre real es Héctor Londoño Villegas. Víctor de la Rosa es una marca.
Listo. Entonces muéstranos, Héctor, de qué se trata todo este espacio.
Por este lado tenemos un escudo, Satanás Rey. Tenemos la cruz invertida en el escudo, que representa para nosotros la rebelión, el rechazo a lo que el mundo conoce como religiosidad, como cristianismo.
¿Y por qué hay un rechazo por parte tuya al catolicismo?
Por todo lo que ha generado alrededor de la historia, por lo que representa, por el gran engaño en el que nos han tenido por miles de años. Ese es un escudo luciferino, representa el bien y el mal.
¿Y el mal qué es?
El mal para nosotros no existe. Sí. Para nosotros es el comportamiento suyo. Como le va a decir hace algo bien, pues obviamente tiene que ir bien la vida, dependiendo de su comportamiento. Nosotros los luciferinos no creemos en el mal como algo que nos impongan. Que si hace esto es malo, que tener sexo con la mujer del prójimo es malo. No, para nosotros no. Es que hacer un pacto con el diablo es cambiar de doctrina, cambiar de religión. Hacer un pacto con el diablo no es otra cosa que acogerse a él, que aceptarlo a él. Yo quise darle el mensaje y llamar la atención en cierta manera en la misión mía acá en la tierra y recopilar almas para él. Entonces hay que mandar el mensaje como la gente lo conoce, un tema como, digamos, de marketing. Hola amigos de Latinoamérica, yo soy Víctor Damián Rosso Villarreal, el representante de Lucifer en la Tierra y fundador del templo luciferino Semillas de Luz, el único templo luciferino en el mundo. No se dejen confundir, no se dejen quitar el dinero, no se dejen estafar. Si se dejan estafar es por incautos, no se dejen confundir. Les habló Víctor Damián Rosso, el fundador de la asociación Templo Luciferino Semillas de Luz.
Cuéntame de dónde vienes.
Yo vengo de familias espiritistas, de santeros, de hechiceros. Mi madre era una reconocida espiritista. Mi abuelo también, él sanaba y maldecía según su conveniencia. Empecé a estudiar yo recuerdo cuando iba a la escuela. Recuerdo que sacaba algunos libros y echaba una tabla ouija. Y me iba a estudiar. Y me iba para el baño y empezaba a jugar con la tabla ouija.
When it's with the Mayas, in the Popol Vuh, in our sacred book, say, when Tepeo and Gugumats, they were here, they begin to watch how the Creator began to do formation of the earth, of the Mother Earth. So Tepeo and Google Maps, they've been watching. So difficult to understand this because where they were Tepeo and Google Maps? They were in some place in the cosmos. And then, because they watched that, so they know the beginning of everything. What the Popol Vuh, they don't say, the monkeys, they were watching how the creator had been doing the world. No? They say Tepeo and Google Maps. And Tepeo is the first creator for everything.
That's why what we're talking about, you and I, that is the waking of the consciousness. We must feel like important people. Before going by to something else, I want to leave a phrase with you for this moment, please. This is a secret for each and every one of you, for your family, for your patients, in your community. Because a lot of people ask, what should I do when I feel my energy is low? When I feel negative energy? What do I do to renew it, to renew myself? Take the energy from the Father, the Son, and give it the movement of your eye. Because the eye never has its very own movement. To look up, down, to the sides, and to the head.
And Google Maps is second, and another is duality. So how we're going to wake up the memory? Only working with the information of the cosmos. Not believing in theories like Darwin.